All right, so we are talking about today about mole ratios. And remember, I know this is like one of the idea of a mole is a very difficult concept for us to grasp. And I totally am not ignorant of that fact. I know it's tough. Just remember, when we think of mole, we think of number. So it's just, we can think of it as the ratio of one thing to another. So really, the coefficients in a balanced chemical equation indicate how many, and this is like, could be the number of molecules, or really we're going to talk about number of moles. The number of balanced chemical equation indicate how many of each reactant particle are used and how many product particles are made. So also the coefficients, the number in front, they always refer to the number of units remember, when going way back when we started talking about representative particles, so things like FUs, molecules, and atoms that are reacting. Not the mass. It's not the ratio of mass. It's the ratio of number. And that's why being able to convert to moles is so important for us in chemistry, because it helps us get to the point where we can convert between products and reactants. So the mole ratio, let me give you the exact book definition here, is the ratio represented by the coefficients in a chemical equation showing how many units of each substance must combine to maximize product. So when reactants, what this means is when reactants are not combined in their exact mole ratios, one of the reactants runs out, and the other is left over. The one that runs out first is the limiting reactant. So you can think about this in terms of, like, say you're making s'mores. In order to make s'mores, for every s'more you need one piece of chocolate, one marshmallow, and 2 graham crackers. Well, if you have 100 graham crackers and 100 marshmallows, but only 3 pieces of chocolate, you can really only make 3 s'mores, right? So your limiting reactant in that case is the chocolate, because it's the one that runs out first. And then you have a bunch of graham crackers and marshmallows left over. You could make something, but it's not a s'more. It's not nearly as good. Right, so the one that runs out first is the limiting reactant. So, using the mole ratio, let's just say we have this reaction, the one we talked about before. So we have copper sulfate, AQ, plus 2 NaOH, AQ, makes copper hydroxide, which is a solid. We can look on the back of our periodic table to figure that out, plus 2 Na2SO4 sodium sulfate, which is aqueous. So let's just say that I had in 2.5 liters of 0.2 moles per liter copper sulfate. Let's just say A, how many moles of CuSO4 are there? B, how many moles of NaOH are needed to react all the way? All right, so we're bringing it back to malaria a little bit. Thought process here. I know if I have 1 liter, it's ratios. If I have 1 liter of copper sulfate solution, I know that in that 1 liter there are 0.2 moles. Well, I know I have 2.5 of those liters, so I know I'm multiplying. Or you can do it the way with the unit cancellation method, where you start with the one that only has 1 unit, use your ratio. So I know I need to get rid of liters, so liters goes on the bottom, 0.2 liters cross out, and I get 0.5 moles of copper sulfate. Well, again, now we're using ratios again, where I want to know the number of moles of NaOH that are needed. Well, I know I have 0.5 moles of copper sulfate. From my mole ratio up here, I know for every 1 mole of copper sulfate, I have 2 moles of sodium hydroxide. So I know that for every 1 mole of copper sulfate, I have 2 moles of sodium hydroxide. So really what I'm doing, because it's just a ratio, for every 1 mole of copper sulfate, I have 1 mole of sodium hydroxide. Well, I have 0.5 moles of copper sulfate, so that means I need 1 mole of sodium hydroxide. All right, so we're going to be practicing this quite a bit. So to wrap up, how can you convert all the reactants to products? Use the coefficient in the chemical equation, and they represent a proportion. That proportion is called the mole ratio. And if they're not combined in their mole, they're not combined in their mole ratio, one will run out, and the other will be in excess. The one that runs out is called the limiting reactant.